Hello, my name is Stephen Glode. I'm a full-stack web developer who's making a video series taking big picture ideas from JavaScript and breaking them down into accessible and understandable formats. Today, we're going to start with the call stack and the event loop. So let's just get into it. Okay, let's start with the call stack. The call stack is a mechanism JavaScript uses to keep track of function execution in your program. It follows a last in, first out approach that can be easily exemplified by our example here. In this example, we have two functions, greet and sayGreeting. Greet just returns hello and the parameter you provided, while sayGreeting sets greet to a variable and console logs that variable. At the end of the program, we call sayGreeting. So we can look at this in our call stack to see how this is going to run. Looking at how this is executed, we can see that in our program we call sayGreeting. sayGreeting is then added to the call stack. However, sayGreeting calls another function, greet. Greet is also then added to the call stack. And since greet calls no other functions and simply returns, greet can be executed, and as it was the last one in, it'll be the first one out. So it is executed first and then removed from the call stack. After that, sayGreeting has to console log to finish, and the console log can be ran, and then it as well can be removed from the call stack. As you may or may not already know, JavaScript is a single-threaded programming language. That means it can only run one thing at a time. So if you look at our call stack here, remembering last in, first out, we will need to execute function 3 and take it off the call stack before we can then execute function 2 and function. If function 3 takes a long time to execute, it'll block the other code from running. This is where the event loop and asynchronous functions come into play to help us out. So in our call stack right now, we have 3 functions. Function 2 is just a simple function, maybe it console logs something. It does something very quickly. Since it's last in, first out, the call stack will look, this was the last function in, so it's going to be executed first. The call stack looks, it's like, all right, I have no problem executing that, let's do it. It runs it. But then the next function it sees is set timeout. Now this is a asynchronous function, so something like set timeout or any AJAX requests like fetch or so. These, the call stack doesn't want to handle them. It's like, this is going to take too long. I'm not here for it. So it gets shipped over to the web APIs. It's there where the web API starts to execute that set timeout or fetch or whatever it may be. And once we move it over there, we can remove it from the call stack so that the call stack's no longer blocked. Then this function can run and execute properly, and there's no blockages in the call stack. Our set timeout that was sent to the web APIs, once it's finished, will go down to the callback queue. And here's where the event loop really shines, and it's quite simple. The event loop checks if the call stack is empty, and if it is empty, it takes the first thing from the callback queue and throws it on the call stack. The call stack can then execute this with no issues, and everyone's happy. We'll take a quick look at an example of this. In this incredibly brief example, we can see how the call stack and the event loop actually work. Now we have our code here, it console logs first, and then there's a set timeout that console logs second after a 2-second delay, and then console log third. Now if there's no event loop, no web APIs for us to use or anything, what would happen here is we would console log first, the set timeout would run, causing a 2-second delay and blocking third from running. However, since we have web APIs, the callback queue, and the event loop, console log first will console log first, as it says, I guess, and set timeout will be sent to the web API where it's dealt with away from the call stack. Since it's off the call stack, we can then console log third, and once the set timeout is finished and it's sent to the callback queue, the event loop will place it back in our call stack to be executed. So if we run this code down here, we can see just that happening. First, third, and second. Thank you guys for watching. That was my brief introduction into the call stack and event loop in JavaScript. If you have any feedback, I'd love to hear it in the comments below.